Okay, so now that we're really good with Leibniz notation, let's go through and use the prime formula for the chain rule. So again, that formula stated, so let me just write both of these up here. So we had dy over dx equals the derivative of y with respect to u times the derivative of u with respect to x. So there's the Leibniz. The prime one said that dy over dx is the derivative of the outside function with respect to the inside times the derivative of the inside. Okay, so one way, if we're doing this, find the derivative of cosine to the fifth x. So I can rewrite that just so I get it in a way where you can easily see how this is going to be using the chain rule. It looks like that. So we don't have a derivative formula for cosine of x to the fifth power, but I do have a formula for cosine of x, so my inside function, and I do have a formula for x to the, or u to the fifth power, something to the fifth power. Okay, so again, we could go through and use Leibniz notation. I'm going to do that really fast. So if I did that, dy over dx, so that's going to be the derivative of y with respect to u, so that's 5u to the fourth, times the derivative of u with respect to x, so negative sine x. But then I'm having to go through and this piece here, I have to still go back through, so I'm going to write that negative sign in front, or that negative in front, but I'm still going to have to go back through and put in what u was. That is essentially finding the outside function, derivative of the outside function, with respect to the inside function. So we can end up kind of going through and skipping a step by doing it the prime way, but it is important that you understand how these all mean the same thing. Okay, so if I was doing it the prime way, so here we'd have our outside function is going to be that x to the fifth power, okay? So if I was doing that, that x to the fifth power would be 5, and then, so 5 times something to the fourth power, if I did that. So that's something, that inside function is cosine of x. So again, what we're doing here is you're basically visualizing, here's my outside, something to the fifth power, so something to the fifth power is 5 times that something to the fourth, times the derivative of the inside. So that's where that negative 5 cosine to the fourth x sine x comes from. So again, it's that if we had this, here's our inside, here's our outside. So if I take the derivative of the outside function, that's going to be 5 something to the fourth power. So that something is the inside times the derivative of the inside. So let's look at another one. So here we'd say our inside function, so our g of x function is the square root of x. Our outside function is the tangent of x. Okay, so if I were to find this derivative, okay, so it's the outside function, so the derivative of the outside function is secant squared with respect to the inside times the derivative of the inside function, which is 1 over 2 root x. So this would be secant squared root x all over 2 root x. So again, if I went through and did this the other way, and you can choose whichever method makes the most sense to you. If I set this up, I'd have u equals the square root of x, y equals the tangent of u, so du over dx equals 1 over 2 root x, and dy over dx, dy over du equals secant squared of u. So dy over dx equals dy over du, which is secant squared of u, times du over dx, which is 1 over 2 root x. And then I have to go through and substitute in what u was. So u was the square root of x. So you still get the same answers. So again, whichever way makes the most sense to you is what I would recommend using. So let's look at an example where we have to apply multiple rules. Find the derivative of y equals the quantity 2x plus 1 to the 5th power times the quantity x cubed minus x plus 1 to the 4th power. So we can see here we have two functions basically that I'm multiplying together. So we will first start by using the product rule. So the derivative of y with respect to x equals, so the first function, so 2x plus 1 to the 5th power, times the derivative of the second, so the derivative of the quantity x cubed minus x plus 1 to the 4th power, plus the second function, x cubed minus x plus 1 to the 4th power, times the derivative of the first, quantity 2x plus 1 to the 5th power. So now we'll take that and we'll find the derivative of each of those pieces. So this becomes the quantity 2x plus 1 to the 5th power times, and this is where the product or the chain rule comes into play. We've got an inside function and then an outside function. So taking the chain rule here becomes 4 times x cubed minus x plus 1 to the 3rd power, and then we have to still take that derivative of that inside function, which is x cubed minus x plus 1. And then we have x cubed minus x plus 1 to the 4th power times, so again we have to in here do the chain rule as well, where our inside function is the quantity 2x plus 1. So this becomes 5 times 2x plus 1 to the 4th power times the derivative of 2x plus 1. When I simplify this out, this gives me the quantity 2x plus 1 to the 5th power times 4 times x cubed minus x plus 1 to the 3rd power times the quantity 3x squared minus 1 plus the quantity x cubed minus x plus 1 to the 4th power times 5 times 2x plus 1 to the 4th power times the derivative of the quantity 2x plus 1, which is just 2. At this point, you can actually keep it like this and put it into MyOpenMath, and it will count it as correct. You can continue to simplify if you would like to as well.